Good morning, everyone. Sorry for a little bit of a delay there, but thank you for joining us this morning. My name is Virginia Batt. I'm the Channel Marketing Manager at Vision Technologies. I want to thank those of you who are returning to us for our third presentation today, and some of you, I believe, are joining us for the first time, so we're very excited to have you on the live call. So today, we're going to continue forward. This is our third presentation in our series of 7. Vision Technologies is a leading IT services company. We're focused on providing integrated technology solutions in both the commercial and the federal spaces. We've teamed with our OEM partner, CommScope, in order to provide you with pertinent information surrounding the life cycle of a DAS system. So moving forward, some of you have seen this calendar, but just to remind you, today is our third presentation, Needs Analysis, and then July 21st we'll be moving forward into our system design. So today, Needs Analysis, site surveys. We're going to explain how to accurately prepare, collect, and analyze your site survey data. Our discussions will include presentations from both Ron and Rick, as most of you have been introduced to them by this point. The session is supposed to last only 20 to 25 minutes, so we're trying to keep it nice and sweet. But please feel free to answer any or ask any questions that you have throughout the presentation. As a reminder, we've muted your phones at this point, but please use the lower box for chat if you have questions, and we will address them at the end. So to get us started, just one quick overview thing here from last time. This should look fairly familiar to those of you who joined us. This is just a corporate overview of both CommScope, and the next slide we'll talk about is Vision. So CommScope is a very large OEM. They support over 100 plus countries. They have over 20 manufacturing facilities and over 11,000 employees. The biggest thing that they're known for is their research and development, as they average about $100 million annually. As you can see, they serve several markets. They're #1 in merchant RF solutions, #1 in structured cabling, and #1 in coaxial and fiber optic cables. Vision Technologies, we're an integrated technology delivery company. In 2014, revenue exceeded $90 million. We have in-house design and engineering services for DAS, PON, wireless, IP surveillance, audiovisual, and structured cabling. As you can see, we can cover several solutions under one roof. Today, I think we're probably, about 350 employees, maybe a few more, 22 states, with past performance in both commercial and federal. I've listed some of our prime contractors at the bottom as well that we hold connections to, Schedule 70, 58I, and we're also working on Schedule 84. If you're familiar with that, it's the security IP surveillance schedule. So these should also look familiar. As I mentioned, Ron and Rick will both be joining us today for the presentation. Ron's email address is here at ronald.pluckus@commscope.com. And also Rick Baldessari, rbaldessari@visiontech.biz. So Ron, I think I'll turn it over to you at this point to discuss today's agenda and a little bit of overview from our past 2 presentations.
The conference has been muted.
Okay, thank you, Virginia. Appreciate it. Thanks everybody for joining today. The agenda for today, we're going to do a quick review of our previous sessions, and then we're going to talk in more detail about developing a DAS solution in terms of the customer requirements specific to the on-site survey, in terms of identifying the physical environment we're talking about, as well as the RF environment, and the analysis of what we have discovered. So in the past, we talked briefly about different DAS considerations, whether it's a passive or an active system, the fact that unlike Wi-Fi, we're dealing with regulated frequencies, and that there's 2 parts and pieces to this. There's the DAS components. There's actually the distribution of the signal, which is actually the DAS, as well as the RF signal coming in, which we call the carrier interface. We talked last, presentations are available at the YouTube links that we've published here. And last week we talked a lot about partner selection in terms of what corporate culture we as an OEM are looking for in terms of responsibilities and responsiveness. We talked about the expertise that we require in terms of design expertise, wireless service provider understanding and savvy, certification to make sure that everything that gets installed is in fact under warranty. And then a key factor in the enterprise space is post-award in terms of being able to support the particular customer with some type of a warranty and some type of service. We talked a lot about the ability of many of our non-partners to provide DAS solutions, and we talked about the fact that one of the strengths that we have is Vision has the ability and the flexibility to be able to partner with those of you out there that may need assistance in a full deployment of the DAS solution. So developing a solution, that's our topic for today. We're going to talk about how we come up with a needs analysis, and that involves a facility survey where we actually go out and take a look at the physical layout, at the radio environment, and logistical factors. By that we mean, what are the rules of engagement in terms of working in the facility. And then from a requirements perspective, we're going to talk, we're going to look into, is this a mission critical situation? What type of ROI are we looking for? Is this public safety or commercial? How many occupants are in the building? That's a huge, huge factor in terms of being able to properly size a system and what the coverage requirements are. We'll talk also about interoperability considerations in terms of LAN or in terms of security. And then from a future perspective, what other areas are we looking to cover? Are we going to add additional carriers downstream or additional services? And then the overall facility layout in terms of, is it new construction? Is it renovation? Is it an expansion? Are there issues that we need to address in terms of aesthetics, in terms of placement of equipment, things of that nature? So when are we going to be allowed to work? Is it daytime work? Is it after hours? That all has an impact on our deliveries. Does the client have a preferred low voltage contractor, which we'll gladly work with? And is it a union or a non-union labor situation? So the site survey preparation, basically we're going to obtain copies of the floor plans. We're going to create a preliminary design. And then we're going to basically pre-configure all that information onto the plans. Do we need escorts for this? Do we need access to equipment locations? Do we need access to the roof? Things like that. So at this point, I'm going to turn this over to Rick Baldessari, who is going to address these in much more detail. So hold on for just a minute, please. Rick? Okay, hold on for just a second, please. Rick, do I have you? Sorry, folks, we're having a little technical difficulty here.
Okay, can you hear me now, Ron?
There we are, Rick. All right, thank you. All right, so without further ado, I'll turn this over to Rick Baldessari.
Thank you, Ron and Virginia, and welcome everybody to the seminar today. And so, I'll pick up here with site survey preparation. And as Ron says, the understanding the customer requirements are critical to a successful survey, because we need to understand whether the DAS is going to be used for public safety, or so the customer can get their occupancy permit, or is it going to be for commercial services to provide employees and staff with access to their cell phones? And the two different applications actually require a little bit different survey and preparation. So knowing whether it is going to be a public safety system or a commercial system is important to know. And also understanding whether it's going to have to interoperate, or if the customer wants it to interoperate with a security overlay or a wireless LAN overlay are things we need to know to properly prepare for the survey, because one of the first things we need to do is obtain the electronic copies of the floor plans of the facility. And with those floor plans, we'll create a preliminary design which will become the blueprint for the survey. So now when the folks are on site doing the survey, they kind of have a preliminary design and understand where to look for cable pathways, where to verify equipment locations, and those types of things. So having the floor plans allows us to create the preliminary design, and so then we need to make sure that the survey tools are properly prepared. So that part of that's inserting the floor plans into the survey PC or tablet, making sure that the batteries for all the devices are charged, making sure that we have whether we're going to do a backpack-based survey, whether we're going to use a cart with wheels and have the tools and equipment on a mobile cart, are all things we need to properly prepare for. As Ron talked about, site access is important. Understanding whether escorts are needed and arranging for the escorts is an important piece of all of this. So if multiple people are going out on site to do the survey and escorts are required and only one escort's provided, well, now you hamper the survey team because they can't split up and work within the facility. They'd have to stick together with the one escort. So understanding escort services and the ability of working, whether it's going to be normal working hours, after hours, are critical things to know up front. Also arranging for access into the equipment locations or access onto the roof may end up being different set of personnel within the building. It could be the maintenance personnel versus the IT personnel. And arranging to have immediate access will make the survey be more efficient and timely. And also preparation is making a list of the tools and materials that you want to take on site with you, so you have them when you're out on site. One of the worst things you can do is say, oh, I forgot this cable, and now without a particular cable to connect up the transmitter, you can't do the proper RF survey. So making a list of the tools and materials you want to take with you will help ensure that you have them. So now, the survey is going to take kind of two parts. It's going to be the physical characteristics and then the RF characteristics. And so this slide here is going to talk about some of the physical things we want to look at within the building. So we want to understand the cable pathways. And, we also want to look at the vertical and horizontal pathways. So vertically, is there conduit available? And is it full or empty? In a lot of the older buildings, the conduit is full, and you can't really install new cable unless you decommission some of the old cable. That may or may not be possible. And if there isn't vertical pathways, we'd have to create them. And so there's various different concerns with when you're drilling through floors and buildings. There's a lot of different things that you may have to take x-rays, may only have to be able to do that at night. And so understanding whether we'd have to create vertical pathways are important. Also with horizontal pathways, are we going to be going through drywall? Are we going to be going through concrete block or maybe firewalls? And repairing the pathway or fire stopping the pathway is very important to understand as part of the entire process. Also inspecting the existing fiber the customer may have. Is that fiber usable for the DAS, or does it have, new fiber has to be installed? So understanding the existing fiber, how it's terminated, where it's terminated, are critical pieces to developing and designing an overall solution. Ceiling types and wall types are important to understand. Whether the walls are drywall or if it's like an attorney's office or firm, there's a lot of wood or marble that could be on the walls. And so understanding, how you would work around some of those type of walls that you don't really want to drill holes through is important to understand where they are and how to work around them. Same thing with ceiling types. If it's drop acoustical tiles, that's probably the easiest type of ceiling to work with versus something that is decorative or hard pan ceilings. And if you're dealing with hard pan ceilings or a decorative ceiling, you've got to look for access panels and may have to create access panels if there's none existing. Also, with drop ceilings, need to understand what's above the drop ceiling. In some facilities, there could be 2 to 4 feet of pretty much empty space. In other facilities that I've been to, it's only 2 or 3 inches of space, and it's very crowded up above the drop ceiling tiles. And so you shouldn't make any assumptions. That's what the survey is about, to physically inspect and eliminate assumptions and guesses so you can come up with a more accurate design. We would like taking a look at the equipment locations, where we want to put equipment. Are those locations have space to install the equipment, whether it's wall space or rack space? Is there the proper grounding elements? Is there proper AC or DC power to power the equipment? And is there the proper amount of environmental controls, both air conditioning and heating, to keep that room at a proper temperature? Also, when you're in the physical survey, you want to understand if there's any aesthetically sensitive areas. And we've talked a little bit about the attorney offices with wood or marble walls, but there's also a lot of times I've seen, lobbies are very decorative and are not necessarily conducive of putting DAS antennas in lobbies, or decorative stairs. There also could be atriums, and atriums prevent multiple floor atriums prevent the ability of putting antennas kind of in that area. So you've got to work around those aesthetically sensitive areas as well. Now, the other part that I mentioned is understanding the RF characteristics. That is going to become important for the DAS design. And so there's several different things that we will do to understand the RF characteristics of a building. One of those is to use a continuous wave transmitter and an antenna, putting them up in certain areas and walking around with a receiver to record the resultant RF coverage. And this type of testing will help us understand if a concrete block wall is a plain concrete block wall, or is it filled with concrete and rebar. The RF penetration between those two wall types is dramatic. Also, if you're in a medical facility that's been renovated over the years, sometimes they've moved the radiology department around, And radiology department implies a lot of lead-lined walls to contain that radiation. Well, if the radiology department has moved, many times the lead-lined walls have not been moved. And so testing with a transmitter and receiver can help validate whether there are any undocumented lead-lined walls in the facility. RF benchmarking means to go out and record the ambient signal strength for the various different wireless service providers that are there. One of the things that has to take place is that the DAS needs to be dominant over the existing ambient environment. So cell phone users will go to the DAS and not try to go to the outside cell tower. Also, the macro serving set. So you want to understand which cell towers are penetrating into the building. This is especially important for high-rise buildings in urban environments where there's a lot of cell towers around, and high-rise buildings will end up, the ambient environment within a high-rise building will end up seeing a lot of the different cell towers. And so now what you have is an issue called pilot pollution, where your cell phone inside the building sees so many cell towers, it gets confused as to what cell tower it can talk to. So if you've ever had a situation where you've got 4 or 5 bars on your cell phone but unable to make a call, that's an indication of pilot pollution and having too many cell towers penetrating into the building. And so RF benchmarking and understanding the cell towers helps us understand how to create a DAS that will provide, the best robust coverage within the building. Also, you want to document and understand where the critical areas of the building are. So while a lot of times those, the coverage requirements are to provide 95% coverage throughout the building, well, if the 5% is the CIO or CEO's office area, and that CEO isn't able to use his cell phone within the building, that DAS doesn't work. And so while it might meet the 95% coverage criteria, if it's not covering that CEO's office, there's a problem with the DAS that has to be corrected. And also you want to have good coverage within meeting rooms. So again, documenting that is very important to understand. So when you finalize your DAS design, you have those critical areas covered. So what are some of the tools that you do to do the RF survey? And these tools are specialized tools and equipment. So it's not just something you're going to pick up at Radio Shack, but these are specialized and expensive tools to do it. A lot of times it's laptops, and now becoming more and more tablets are used because of their lightweight. And we connect multiple user equipments to those tablets. Now UEs is a fancy term for saying cell phones. So we'll use a tablet computer, connect multiple cell phones to that tablet computer, run specialized software, and record the ambient signal strengths that are within the building. In addition to utilizing cell phones, we utilize scanners, and scanners will help pick up public safety and other signals as well. We talked about using a continuous wave transmitter to help us test the in-building RF propagation between walls. There's also devices called spectrum analyzers or BTS analyzers that allow us to actually view the RF signals that are taking place within the building. So the spectrum analyzers give us the ability to see physically the RF on a screen, and the BTS analyzers give us a lot of the macro serving site information. It'll tell us what cell towers and what signals and technologies are being viewed within the building. And also, part of the tool list is a simple checklist and a task list. So now, you want to have that checklist of things to do while you're on your survey to make sure that you record and collect all the information that you're supposed to collect. Last thing you want to do is come back to the office, start looking at the data that you've collected, and realize you've missed a whole bunch of information because you forgot to take it. So having that checklist is extremely important. Also extremely important is a camera to take pictures. I know with myself, I don't want to rely on my memory, but taking pictures of all the equipment locations, different ceiling locations, different aesthetically sensitive areas are very important, so the dash designer can see what you saw, and it also becomes a point of reference, so you can go back and review something that you might not remember correctly. So once you have all the data collected, you need to analyze it. You need to document it. So you want to, create on the floor plans, cable pathways that you can and can't take. So if the preliminary design is going through an atrium because the designer didn't realize there was an atrium there, you need to reroute those cable pathways. Again, document the ambient RF signal so the DAS can be created to provide dominance and the proper soft handoffs that will take place between the ambient and the DAS. We want to understand where the elevator and the stairwell locations are. So if you have antennas on one side of the elevators, you know that coverage is not going to penetrate too well and reach on the back of that elevator. So understanding where these major RF blockages are, such as elevators and stairwells, are important to note on the floor plans. So in summary, the key is preparation, 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 making sure you understand the client expectations, how to get in and out of the site, utilizing that preliminary dash design as a blueprint, making sure you have your survey tools properly configured and collected, having that checklist to make sure everything is collected. And during the survey, stop and make sure that the data, you are actually collecting the data. And again, as I said, take plenty of pictures and notes and analyze the data as soon as possible after the survey while it's freshest in your mind. So with that, I'd like to turn it back over to Virginia for our Q&A session.
Thanks, Ron and Rick, for your presentation today. We really appreciate it. We've had a few questions come in, and I think between the two of you, we can get most of these addressed. So Ron, maybe you can talk to this point. I know this is something we've had discussions on before, but how does a LEED certified building impact a DAS?
Thanks, Virginia. LEED certified buildings, those of you that are not familiar, are basically green buildings, and they have certain requirements that, to get certification for them being a different level of LEEDs, whether it's platinum or gold. As an OEM, we really enjoy and like LEEDs buildings because one of the things they do is they have special treated low E glass windows in these buildings. So the good news is these low E glass windows keep all the environmentals working more efficiently in terms of heat and cooling and things like that. The bad news is if there's a cell site across the street, the signal will not penetrate the building. So if it's a LEEDs building, you can pretty much be guaranteed the fact that they're going to need some kind of help. Virginia?
Thanks, Ron. Rick, here's another question that was just asked from the group. Can you please further explain DAS dominance as well as soft handoff?
So the DAS dominance is to, again, make sure that users inside the building will connect to the DAS and will not connect to the outside macro network. And soft handoff is the period of time that it's the transition between the inside and the outside environment. So when you're walking from outside into the building, you don't want to drop your phone call. And so the soft handoff is the terminology used to make sure you have a seamless transition from the inside DAS to the outside or from the outside to the inside so you can continue talking without dropping the phone call.
Thanks, Rick. Ron, here's another one that you could probably speak to your experiences, but we've been asked, what types of cabling challenges have you experienced, and how about RF challenges, in particular the impact in a hospital?
Yeah, well, Virginia, hospitals are a totally different environment than most other facilities. Many of you may recall not too many years ago when the first sign you saw when you walked into a hospital was a big picture of a cell phone with a circle and an X through it. And that was back in the days when the early days of DAS, where there were concerns that there might be interference with some of their medical equipment. All of that has been addressed, and it's not an issue today. But for example, if you're working in a hospital environment, one of the things that they may require is something called tinting, T-E-N-T-I-N-G. And what that involves is actually having, every time you're required to open a ceiling tile, they want you to tint around that particular work that's being done and put out cones and things like that. All hospitals don't require it, but if they do, that has an enormous impact on the labor time that's involved, because this may have to be done during different hours. It slows down the normal process. So that's probably the biggest thing we see over and over again that needs to be taken into account when you're out there asking those questions on the site survey.
Great. Rick, here's another one for you that just came in. What are the major differences between public safety and private for a site survey? Are there any special considerations?
Yeah, so the differences and special considerations regarding public safety versus commercial DAS is a couple of pieces. First, public safety, the radios are a little bit stronger than cell phones, and so coverage requirements are typically down to a neg 95 signal strength, dBm signal strength, versus cell phones, depending on what measurements you look at, it would be like a neg 75 received signal strength indication. So cell phones typically need a stronger and a cleaner signal than public safety radios. But in addition to that, public safety, the first responders, they need to have access in stairwells, in mechanical spaces, in the fire control rooms, typical areas where people are not during the business day. So employees, staff, and visitors are in the office areas. Firefighters, first responders are more in the infrastructure of the building, mechanical spaces, stairwells, and the such. So, where in the example I talked about, where if the corner office does not have cell phone coverage, that CEO is going to consider the DAS a failure. First responders really don't care too much about the corner office. They're worried about the stairwells. And so that's kind of, the bigger differences between public safety and commercial or private DAS.
Thanks, Rick. Maybe this is one more that you can address before we finish up today. Is there any type of checklist or anything that you like to use when you go out on your site surveys?
So yes, at Vision Technologies, we have a survey checklist form that we use, and that checklist contains a lot of the information that I went over today. talks about, what are the ceiling types, what are the wall types, the cable pathways, looking at the equipment closet locations, validating, grounding, AC power, AC, heating and cooling controls. We have in there, make sure we record ambient signals, at the rooftop, at the entrance, at the entrances and exits of the building, so we can make sure the soft handoffs happen properly. So these are all specific things that we have on our task list. That I went over with today. We also have on that checklist is make sure you bring the survey tools, the transmitters, the spectrum analyzers. Make sure we have our cables, our jumpers, attenuators, so we can, utilize the tools. Make sure we have tripods are all on the checklist as well, to make sure we have the right tools with us and to make sure we record the right information while we're on site doing the survey.
Okay, I think that's all the time that we have. I apologize, we ran a few minutes over. Thank you for the questions today. Just to remind you, our next presentation will be on July 21st. Also, we've listed on this slide for you our YouTube channel, Vision Tech Videos. You can review the past two presentations, and we will be loading this presentation. So thank you. We hope everybody has a great rest of the week, and we will talk to you again in July.